Welcome to aminacademy.com. In complex analysis, let us do an overview of complex numbers continuation. Now, operation with complex numbers. Let us discuss. Now, first we'll talk about let Z1 a complex number x1 plus y1I. Z2 equal x2 plus y2I. First we'll do addition. Addition of complex number, that is Z1 plus Z2 equal, add the real part of both complex number x1 plus x2 and add the imaginary part, that is I into y1 plus y2. Next, negative of complex number. Negative of here Z1 is x1 plus iy1. Then negative of Z1 is negative Z1 is equal real part negative and imaginary part also a negative. Subtraction. Here Z1 minus Z2 equal real part of first minus second, that is x1 minus x2 plus imaginary part subtraction, that is y1 minus y2. Next, additive inverse. Additive inverse is suppose Z1, let Z2 is a additive inverse of Z1 if the condition Z1 plus Z2 equal 0. Therefore, we can say from this we can say Z1 equal minus Z2. Therefore, we can say Z1 now is equal minus Z2. Suppose minus Z is minus x1 minus x2 minus I y2. Similarly, you can say Z2 equal to minus Z1 also, and that Z2 can say minus x1 minus I y1. Next, multiplication of two complex number. Multiplication of two complex number. Here is Z1 into Z2 is x1 plus iy y1 into x2 plus I y2. So, which gives After multiplication, we will get the result like x1 x2 minus y1 y2 plus I times x1 y2 plus y1 x2. This is a result of multiplication of two complex number. Now division. Division equal z1 over z2. We are having z1 is x1 I y1 over x2 I y2. Here we have to rationalize the denominator. That means denominator have x2 plus I y2. So you have to conjugate is x2 minus I y2 you have to multiply, which is equal x1 I y1 x2 I y2 into x2 minus I y2 and x2 minus I y2, which gives, after multiplying and simplifying, we'll get x1 x2 plus y1 y2 over denominator have x1 x2 square minus I y2 whole square, that is become plus, because I square is minus 1, already minus is there, so plus, so it becomes x1 square plus y1 square. This is the real part, and imaginary part is x1 y2 minus x2 y1 over x1 square plus y1 square into I. This is a division of two complex numbers. Now next, reciprocal of complex number. Reciprocal of a complex number. Suppose reciprocal of z1 is 1 over z1. So we have to do 1 over z1 is x1 y1I. So you have to rationalize the denominator, that is x1 minus y1I over x1 minus y1I, which is equal x1 square plus y1 square over x1 minus y1I. So this is a reciprocal of z1. Next we'll talk about the properties of operation with complex number. That is, we can say simply a set is closed under both addition and multiplication. Addition and multiplication are associative. First, addition and multiplication is properties of operation. Properties of operation of a with complex number. Numbers. Here consider z1 and z2 are two complex numbers. Here first is addition and multiplication are commutative. means change the order, have same values. Means z1 plus z2 equal z2 plus z1. For addition, for multiplication, z1 into z2 equal z2 into z1. Its next is associative. Addition and multiplication are associative. Addition and multiplication are associative. Now consider three complex numbers z1, z2 and z3. Now for addition, z1 plus z2 plus z3 is written as z1 plus z2 first added, then added that result with z3 same values, and same for multiplication, z1 into z2 into z3 is equal first and second is multiplied, then multiplied with third is also same result will come. Next is multiplication is distributive over addition. Addition is distributive over addition in complex number. That means, look here, suppose z1 into z2 plus z3 is equal to z1 z2 minus z1 z3. Also in subtraction also, over addition and subtraction, both it is. So z1 into z2 minus z3 is equal to z1 into z2 minus z1 into z3. For every non-zero complex number has a multiplicative inverse. Now first additive inverse and multiplicative inverse. Additive inverse of z1 is minus z1. Multiplicative inverse of z1 is is 1 over z1, that is z1 or minus 1. We can do that. Now next we'll do an example for inverse something. Find multiplicative inverse of, example, find inverse of 3 plus 4i over 4 minus 5i. Here multiplicative inverse of 3 plus 4i over 4 minus 3i is just reciprocal, is 4 minus 3i over 3 plus 4i. Then we have to rationalize the denominator, that is 3 minus 4i over 3 minus 4i, which is finally is 3 square plus 4 square, and top is 3 into 4 is 12 minus 16i minus 15i plus 20i square. So which simplify gives minus 8, because 12i square is minus 1, that is minus 20 plus 12 is minus 8 minus 31i over 25, which is equal minus 8 by 25i minus 3i by 25 is the multiplicativeness of the given complex number. Next one, conjugate of complex number. Conjugate of complex number. We can say conjugate of z1 is z1 bar. Suppose take one example. Z1 is already we have x1 plus iy1. Therefore, conjugate you can write as z1 bar equal x1 iy1 whole bar, which is equal, conjugate means only change the imaginary part of the sign, that is we have x1 minus iy1. This is a conjugate of now. Further videos will continue. We have done. Please subscribe our YouTube channel.